All right, let's go ahead and run through section 2.15 and 2.16. Start thinking. It says, remember that you can subtract equations when the coefficients are the same or add when the coefficients are opposites with the goal of eliminating a variable. We have already gone over and solved equations by graphing. We know you graph the two lines and the intersection is going to be your solution. We solved by substitution. Substitution is getting one or both of the equations in x equals or y equals form, and then substituting into the other equation, solve for one variable and then solve for the other. And then yesterday we talked about elimination. Once again, just like this said, you can add or subtract your two equations with the goal of eliminating a variable, because once you eliminate a variable, you can solve for the remaining variable. Remember, when you are adding two equations together, it's basically the same as adding the same thing on both the left and the right. So in this case, in the problem that I have below, when let's say you added these equations together, even though it looks like you're adding 3x minus 1y to the left and something different, 4 to the right, since those things are equal, you're technically adding the same thing to both sides. Now let's go back to what we were actually supposed to be doing here. It says solve the following system of linear equations by elimination. So when I gave this to the students, I said, do you think I should add or subtract them? And one student said add. So we added them together and saw that neither of the variables were eliminated when it was left as is. And then they said, okay, well, if it's not add, then subtract them. And we subtracted it, and neither of the variables were eliminated then. So I said, well, what are we going to do? I then talked to them, look on the right. This is something that you guys should be familiar with from previous math classes, but it's just the concept of what you do when you are adding fractions. So when you started learning how to add fractions, your teacher may have given you stuff with common denominators. For example, 1/4 plus 2/4. And since it has a common denominator, it's already set up to do the problem. You just add your numerators and put it over the common denominator and everything is good. At some point, your teacher is going to move to a problem like 1/4 plus 1/2. And while you cannot add immediately because you don't have common denominators, you don't just give up, you get a common denominator. And in this case, you can leave the 4 and then you would just change the 2 to be a 4. You would make it so that both of them had a common denominator of 4. And then after you were comfortable with that, your teacher gave you a different type of problem like 1/3 plus 1/5. And not only did you have to change one of the denominators, but you had to change the other one as well. So bringing us back over to what we were talking about with elimination. Just because you cannot eliminate a variable by adding or subtracting as is does not mean you can't do it. What we're going to do instead is we are going to get one of the variables, the coefficients on the variables, to be the same or opposites. I always prefer opposites, so you can just add. So when we looked at this, if I wanted to make the 5 and the 3 the same, it's just looking at the least common multiple of 5 and 3. And the least common multiple of 5 and 3 is 15. So you have to multiply the top by 3 and the bottom by 5. That's two things you need to do. If you wanted to make the y's the opposites, all you have to do is multiply the bottom one by 2. So that's what we did. We multiplied by 2. It made it so that the y's were opposites, and then we were able to add together. Now you're going to be very careful. I need to emphasize this a lot. A lot of people will multiply the 3x and the minus 1y by 2, but they forget to multiply the 4 by 2 as well. So you've got to multiply everything by 2 because the rules of math say whatever you do to one side, you have to do to the other as well to keep everything equivalent. So as you can see, we got the 2 and the -2. When you add it together, you solve, you get x equals 2, and then you just substitute it back in. When you substitute it back in, you end up getting y being 2. After that, we just ran through 3 different problems here. On the first one, once again, you can make the first numbers, the coefficients, both 15 and -15, but you're going to have to manipulate both equations. Or you could just manipulate the top equation to make it a -6. When you make it a -6, now they're opposites. You would be able to add them together, solve for the first variable, substitute in, and solve for the second variable. Now on number 2, when you're looking at this, you don't want to just multiply the bottom one by 3 because then you're going to have to subtract. Why not just multiply by -3 so that they're opposites and you can add? We're always hoping to add rather than subtract because when you subtract, you open up the possibility that you are going to mess up with minus negatives. As you can see, I multiplied the bottom equation by -3, making the y coefficients opposites. I added the equations together, getting x equals -3, and then I substituted back in to find out what my y value was. Now on the next one, on this next problem, you cannot just multiply 3 by something to get 2 or 2 by something to get 3. You were going to have to multiply both equations by something. It's kind of like when you had two fractions where the example I had right here, where it was a 3 and a 5, and you had to manipulate both of them to get a common denominator. So what I did was I decided to get rid of the x's. I multiplied the top one by -2, the bottom one by 3. That gets you your -6x and your 6x. And when you add these things together, you end up getting your y equals 8, and then you sub it back in to either one of the equations, either the originals or after you manipulated them, and you're able to get x equals -10. The students then practiced on their own. I gave them one problem that was a little easier, number 1, and then number 2 was much more challenging because you ended up with ugly fractions. So on the first one, you could either get the 7 and the 3 both to be 21 and -21, but you'd have to manipulate both equations, or you can just multiply the bottom one by -2 so that the y's were opposites. Multiply by -2, add the equations together, and you end up getting x equals 2. Sub it into either of the equations or the ones after you manipulated, and you end up getting y equals -3. Now on the second one, you are going to have to manipulate both of the equations because it is one of those ones where you have to multiply both of them by something so that you can get that, that opposite coefficient. So I decided to get rid of the x's and I made them 12 and -12. You can see that work on the right side. When I solved this, I got a really ugly answer of -11/18. I checked to make sure that I did this correctly, and then you add the choice. Actually, you don't know that you have a choice, but what you would normally do is substitute that in for y and solve for x. But we all know that if we try to substitute an 11 over -18 in, we're probably going to mess this up. So the trick is all you do is start the problem over again, but in this time you are going to just get the other variable eliminated. So instead of eliminating the x's, we eliminate the y's. So we get them to be opposites by multiplying the top by 3 and the bottom by 2. And then we were able to solve and get 19/18. So that makes it a little easier. Now our real world problem here is talking about a teacher who decides to buy calculators and measuring tapes. One time that she goes, she buys 20 calculators, 10 measuring tapes, and spends $495. Second time she goes, she buys 8 calculators and 1 measuring tape and ends up spending $178.50. So the two equations, the two totals we can talk about here are the total money spent on trip 1 and the total money spent on trip 2. You can see the two equations that I have here. It's 20x plus 10y equals 495. 8x plus 1y equals 178.5. It is asking what is the solution going to mean? What is the solution to either one of these equations or the solution to the system? And it's going to not be the number of calculators and the number of measuring tapes, it's the cost of a calculator and the cost of a measuring tape. Then we went over and solved. We ended up getting $21.50 and 6.5. Those are the prices of a calculator and a measuring tape. And the way that I checked if my answer was reasonable is I had this graph over here that I had for the graph of equation number 1. And if this is correct, for my answer to be at least reasonable, 21.5, 6.5 better be on at least this line. It should be on the other line as well, but since we don't have the other line graphed, I'm not able to check that. But if you look at 21.5 and you go over, you see that it is about at 6.5. So our answer is reasonable. If we solve this by graphing, the intersection would be at 21.5 and 6.5. Now, we have learned how to solve by graphing, elimination, and substitution. This next question just says, does this look like it would be better to solve by elimination or by substitution? So A, since they're already in y equals form, why not solve by substitution? It's already done the work for you of getting it in y equals form. All you have to do is substitute in and solve for your first variable and then your second. B, on the other hand, is in standard form, so it is ready for elimination. And not only that, but look, the y's are opposites. And since the y's are opposites, then they are going to be eliminated very easy without even having to manipulate either of the equations. And then lastly, that one would be another substitution problem. The reason it's substitution, in my mind, is because one of them is already in y equals form, which means it is ready to substitute into the other. Now this last problem just said thinking problem. What is a possible equation for line number 2 given all of the characteristics seen in the graph and your knowledge of a solution? So I can see that this has a negative y-intercept, a positive slope, and it also better have 2, 1 as a solution. So there are many, infinitely many equations that this could be. The one that I did was I had a positive slope of 2, a negative y-intercept, so -3, and then I just made sure that 2, 1 worked, meaning it made the equation true because it's a solution. Now let's take a look at the homework. On 1a, I intentionally made it so all you had to do is manipulate one of the equations. You just multiply the bottom one by 2, and when you do that, you can solve for x getting 2, sub it back in, get -2 for y. On the second one, I didn't want you to just have to multiply one of them by a number. I wanted you to have to multiply one of them by a negative number. So the easiest way to do the second problem, b, would be multiplying the bottom equation by -3. If you did something wrong, check if you multiplied all 3 parts of the equation by -3. And then C, you had to manipulate both equations. And when you solve this, you end up getting some icky answer of 12/7. Now, could you substitute 12/7 into either one of the original equations or the ones after you manipulated? Absolutely, but it's going to be easier just to then go back and start over and eliminate the other variable. And when you do that, you get -9/7. So that is how I would do that problem. Eliminate one variable, then eliminate the other. Now in this problem, it says that someone is buying 3 child tickets and 2 adult tickets, cost is $19, then buys 1 adult ticket, 2 child tickets, and it's $11. First part is what is the equation? Be 3x plus 2y equals 19, 2x plus 1y equals 11. What does the solution of 3, 5 mean for this? It does not mean 3 child tickets and 5 adult. It means $3 for each child ticket and $5 for an adult ticket. When you add the equations together, you get 5x plus 3y equals 30. What does this mean? Well, this means if you bought 5 child tickets and 3 adult tickets, it would be $30, which makes sense for the problem. If you combine the 2 times that he bought tickets, it would be 5 child, 3 adult, and it would come out to be $30. And yes, it is going to be the same solution that is a solution to each of those equations is going to be the solution to the equation after you add them together, because it's going to be the same price for a child ticket and an adult ticket. The next question says, which of the following explains why you legally can add 2 equations together? Is it that the 2 equations have different slopes? No. Is it that they do not have common coefficients, so you can add them together? No. Is it since 2x plus 6y equals 11, when you add 2x plus 6y to one side and 11 to the other, it's like you're adding the same thing? Yep, that's it. It is not D either. It's not just because the numbers are close to one another. Now on this problem right here, it says that a person wrote out an equation. They said that it was the same problem that we had in the quiz, where it's talking about non-food items not being taxed and non-food items being taxed and the food items not being taxed. And they say this was the situation. It was $25 non-food item and a $6.75 food item. List the mistakes that the person made. Well, there's 2 mistakes. Number one, they said 9.25% is just 9.25. It's not. It's 0.0925. The other thing is when you go over and buy something from the store, you don't only pay tax. You have to pay tax on top of the cost of the item. So not only did they pay the tax, which is 25 times 0.0925, but they also had to add another 25, which was them paying for the actual item. The next thing that they did, those were the 2 things. They represented 9%, 9.25% incorrectly, and then they did not add the cost of the item. The next one here says Tyrone and his 3 friends are starting a business mowing lawns. They make $40 for each lawn that they mow, but they had to buy a lawnmower for $150. Tyrone thinks that the expression below represents the money each person will make. Explain the 2 mistakes. Well, number one, it's saying plus 150, and they spent 150 on the lawnmower, so that should have been a minus 150. And the other thing is Tyrone and his 3 friends. So altogether, there are 4 people in this business. You would divide by 4, not by 3. All right, hopefully that all made sense. Thanks for watching.